Hope you all enjoyed your lunch, and I appreciate your presence here because you did not pass out after the wholesome lunch and brought yourself back into the ballroom. Thanks for being here. So today I'm going to share some insights on future trends in DevOps. My name is Manivannan. I work as Vice President Tech Manager. I lead group of developers and DevOps engineers. So this is what I deal day in and out in my everyday life, right? So let's just move on. Can I move the slides? Sorry, I didn't take. Thanks. For next 20 minutes, I'll walk you through these topics. First, we will take a look back into the legacy developers world and fast track it to this day. Then we will have a glimpse over the DevOps adoption maturity model as of today. Then we'll take a sneak peek into future trends in DevOps. Then I'll take a deep dive into all the 4 trends: DevSecOps, AIOps, ModelOps, and GitOps. Right? We had enough discussions and presentation on these topics, but let me give my insights and perspective on these topics as well. All right. So before we get started, may I ask you this question? So how many of you have been a developer for at least a decade now? Developer and DevOps engineers, at least for a decade? Okay. Hope you could relate this picture to your 2010s developer ecosystem. So basically you have 3 teams in the developer ecosystem. The engineering team, which underpins the entire developer ecosystem stack. They basically build everything underneath the infrastructure, like building the operating system, configuring it, and then rolling it out to the developers or DevOps engineers. They set up the basic network, they set up the storage, they set up all the underpinnings of our infrastructure. Then it's handed over to the DevOps engineers, who then develops your middleware stack, your server stack. They configure it, and they also do some level of CI/CD setup. Then there comes our hero developers, who design and develop things, and then take it all the way to production. Now, if you see in today's world, these 2 layers have converged into one: DevOps and engineering, or I would say the engineering layer is totally wiped out. It's about DevOps and Dev, because DevOps absorbed the complexity and mundane manifold involved in engineering, and they are able to provision the infrastructure as a service by taking full advantage of IaaS, infrastructure as a service, or IaaC, infrastructure as a code. Now, the path forward will be DevOps will be absorbed by developers. A strong developer can provision all by himself, right? A strong developer can provision infrastructure services all by himself, and he can set up his own CI/CD pipeline. So a strong developer means he can run the whole show all by himself, right? And likely that the DevOps role will disappear, and it's all within developer world. I know this is not a nice thing to say in a DevOps conference, but just being honest, right? Okay. Let's look at the developer adoption maturity model as of today. Both pictures might be familiar to most of you. The picture on the left side is a non-cloud architecture reference model, where you have a bunch of tool chains throughout your DevOps lifecycle. So you have Git, Jira, and a bunch of Atlassian tool to help you with the development. Then you have tools like Maven to help you with build. Then Jenkins helps you for CI and CD. And we have a whole bunch of automation tools like Ansible to orchestrate the flow. And you have observability tool. So if you are not on cloud, if your enterprise is running totally in-house, this is your reference model. And alternatively, every single cloud service provider offers their own DevOps stack. I have taken an example from AWS. So when you host your applications completely on cloud, you have a complete DevOps offering on the cloud. In Amazon's case, you have code build to manage your builds, and you have code pipelines to set up your CI/CD, and you have code commit to manage your repos, and you have Beanstack, which is a kind of a middleware right out of the box server stack to run your applications. And again, as you know, AWS has a whole bunch of observability and monitoring tool to manage your applications. So most of the enterprises are adopting either one of these two as of today. Either they are completely on-premise, or they are on cloud, or they adopt a hybrid approach, which is common these days as well, right? And from here, we want to go straight into have a look at the future trends in DevOps. Okay, so there could be more trends, right? But the ones which are promising are DevSecOps, AIOps, ModelOps, and KitOps. I don't have to say more about DevSecOps because from morning to evening, this is what we've been hearing in this ballroom. So let's start with DevSecOps. So I put together everything I know about DevSecOps in this slide. And if you could grasp and absorb this is all DevSecOps is about, right? People talk about shift left all the time. Let's start with that first. Shift left is a mindset or is a culture where you move security at the outset of the project development. See, as you know, security is a serious business, even if your industry is into game development, right? And if you are a financial institution, you are highly regulated, where security is a critical element throughout your application lifecycle or management. Now, earlier when the house is on fire, the InfoSec team will roll up their sleeves and attend the incident. But now, the security is responsibility delegated to every single person involved in the organization. And shift left is very popular culture within security world where the security processes are blended into the onset of software development. So to start with the design and architecture, secure by design, let's talk about secure by design for a second. Any of you are familiar with this terminology, SPD, secure by design? Okay, could you throw some light? Could you give a random definition of what it is? Nobody can give, I know, because this is a try topic. There is no definition as such what secure by design offers, in fact. This is a totally try topic because secure by design is again a cultural phenomenon where it mandates you to have a security as part of your design and architecture. There is no blueprint as such, but as you design the system, ensure that this system is secure by design, be it an infrastructure, be it an application, be it anything within the enterprise setting, it should be secure by design. That's the mindset. And threat modeling, regulatory requirements are taken into consideration as part of the design. And there is another phenomenon which I haven't put in the slide, but let me call out. Security off the cloud, security on the cloud. I hope many of you would have heard of these terms. Last year, if you see, Amazon was running very big campaigns all around, and these two were predominantly discussed in all their security conferences. Security off the cloud, security on the cloud. Security off the cloud is the responsibility of the cloud providers, and security on the cloud is definitely the responsibility of the enterprise which hosts the application on the cloud. And that's again part of shift left culture. And some of you may be familiar with threat modeling, which is done at the onset of the design and architecture. And of course, you have to abide by the regulatory requirements in whatever jurisdiction you operate on. And there comes your build stage, where you spend significant time in developing your application or software. Secure coding practices very much enforced in all the applications, especially if your application is bound to regulatory requirement and scrutiny. There are a whole bunch of tools in the market, but Checkmarx is famous one among the banking industries and financial institutions. Then SAST is again security analysis tool for software. Checkmarx is one of the item. Software composition analysis, then CVE, code vulnerability management, fast risk, third-party risk, etc. So these are the whole bunch of checklists that you will address during the time of software development itself, rather than having to wait until the software is developed and delivered. Then you have QA validation process, where you will scrutinize your application through penetration testing, test, IAST, and stress testing. Someone asked a question from the audience to the panelist in the morning. So let's say you buy a software from a vendor and deploy it in your enterprise setting. You don't have access to the source code. Now, how do I ensure this system is secure or the software is secure? The answer is test. Dynamic application security testing. So this basically tests from a black box testing perspective, right? So it exploits the vulnerabilities of the software at runtime. One example is IBM AppScan, if you guys are familiar. IBM AppScan simulates the user behavior and user loads and exploits the vulnerability of the application during the runtime. Then IAST tool, interactive application security testing. And there comes stress testing, which again puts your system under stress and load, very similar to penny testing. So this is additional security validation on top of the functional validation, of course, you do for any software development. Then there comes your release phase with a whole bunch of other checklists to satisfy DevSecOps. So I'm not sure how many of you heard of this, developer versus deployer toxicity, where the R&R roles and responsibilities are segregated between these two groups. And developers are ensured that they don't have deployment access, etc. And that again is a phenomenon under POLOP, principle of least privilege. Then software security configuration management, where you manage your keys and other bunch of secure data like password, etc. Then environment hardening is again a part of release security checklist, where you will scrutinize the environment, be it a staging stage or a production stage, to ensure that no other unnecessary software is running on that environment. Let's say if you have SSH running, or SFTP running in the environment, which may be unnecessary, that should be eliminated as part of environment hardening technique. Then comes your immutable deployment, where your pipeline ensures that the application which was deployed in the lower land is deployed in production by matching the checksum. So you can be sure that your application is immutable. Then there comes your customer-facing and monitoring related security checks. When your application is BAU, serving customer traffic, and you're under operate and monitor phase, you have a whole bunch of security tools watching your application's performance as it faces customer. Threat intelligence, logging and alert system, incident response, RASP and WAF, web application firewall security. So this is the DevSecOps culture, right? And any enterprise which is maturely handling DevSecOps and is serious about DevSecOps culture definitely checks most of these boxes. There may be more tools, but definitely these are the ones which are commonly adopted in industry. Then AI ops and trends. This is again a dry area. This is still solidifying. The landscape is so fragile. Nobody could define what AI ops is, but if you don't read about this topic on Reddit, so there are many haters on Reddit who thrashes folks who talks about AI ops, because they call this is really a vague phenomenon. It is not. If you see, there are things that you need to stitch together so that it makes sense. AI ops is one of them. Let me try to make some sense. Let's approach this topic from 3 angles, right? Automation, engagement, and observability. Let's talk about automations. So pretty much everything is now going through automation. Let's start with the development phase, right? You guys are familiar with ChatGPT. You must be. So ChatGPT writes code. And yeah, I know ChatGPT writes better code than many of the other tools. But you have Amazon Code Whisperer that offers plug-in to your developer IDE, similar to the way GitHub Copilot offers. Then your development time is accelerated, right? You don't have to again write boilerplate code or look on the internet or Stack Overflow to extract the repetitive algorithm or the logics. This IDE plugin can generate on the spot, and it's easily integratable within your IDE and code system. So the automations start right from your developer environment. And then as you move forward, let's talk about observability phase. I think in some of the sessions, they have mentioned quite a few tools, AI tools for observability and monitoring. Let me call out one peculiar case where you have Dynatrace Davis. Anybody used it? Wonderful. So I'm not expert in that subject, but I have had a demo, and the features were amazing. So it has predictive AI, casual AI, and generative AI features. Let me explain. So AppDynamics is quite a famous product in observability and monitoring area. Predictive AI is the phenomenon where it can generate patterns and alerts based on anomalies and the traffic patterns, which helps you to make decisions. Then casual AI is a phenomenon where it groups all the related anomalies and pinpoints the area where there is a bottleneck, and again generates reports based on that. And there is another phenomenon within Davis called generative AI, which basically helps you to generate the queries and the dashboard on the fly. Okay, and there is something missing in this area. If you see, if these tools can integrate a plain simple LLM, right, like ChatGPT, then you can straight away ask questions like, tell me how many times this feature was accessed in the given interval. It will give the count. And I ask questions like, I want to see how many times I got this exceptions from this Java applications. It just gives me the number. Then I ask again further aggregated questions like, within this period, what's the peak count, etc. So basically, it is able to understand the natural language, and it's able to generate the response from the data logs or the traces it aggregates. So that is sort of an emerging area within the AI observability space. I am not sure if it's there with any other tools in the market yet, but this is one area to watch out. Then let's talk about engagement a bit. So I am sure most of the customer-facing applications are now integrated with the virtual chatbot, right? So it's no more a call center helpline for many industries. It's through a virtual chatbot assistant where you type in your query and it responds with a bunch of possible answers, and you pick one or two. Then based on that, again drives you into a different direction. And then if at a point you will come to an agreement that that's your actual problem that you're trying to solve, or it's maybe an order inquiry or anything of that sort, then the chatbot prompts you if it's okay to create an ITSM ticket or a relevant ticket to track the issues further so that a human can attend. And as you give your consent, a ticket is raised in the system. An environment-related issues, it can raise a ticket within ITSM for further engagement. And that's another emerging model within AI observability space where you use virtual chatbot assistant to create ITSM ticket and then forward it to a human to resolve it, right? Okay, then let's talk about model ops. So are there any machine learning engineers here who developed some ML? Okay, not many. Okay, fine. So then let me talk a bit about this. So definitely model ops or ML ops is not going to be the same as DevOps that we have today to manage enterprise applications, right? As you can see, this is a random picture, but let me try to make some sense out of it. On the left side, you have a process related to data management, like data pipeline tools, data science workbench, wrangling workbench, etc. This is theoretical purely, but let me also give you a real-time example in a moment. But let's try to understand this. So on the left side, everything starts with the data, sourcing the data, scrutinizing it, cleaning it up, then wrangling, and then model management, where you develop a model and you feed the data to train the model, then it follows a circle, it follows an iteration, then the model gets mature, and the model is deployed to serve several other business use cases. This is the ML model pipeline. This is not very similar to the enterprise application development pipeline that you have in the industry today. It's a lot different, right? So if this is going to sink in your mind, then let's recall a real-world example with Amazon SageMaker or Bedrock, right? So Amazon SageMaker is AML development platform offered by AWS. If you are there, then you will know the you will know the typical challenges with machine learning application development. Basically, your data sources are heterogeneous. You may be collecting data from S3 bucket or DynamoDB stream or from a Genesis host. Then the data is pumped into another source for scrutinizing it or cleaning up or extracting the metadata out of it. Then the SageMaker provides a platform to manage your machine learning models, where you can develop a model from the ground, or you can pick one from the model hub and then enhance it. And then you can use the source data to train the model, and you can iterate it. Then the model can be saved into a registry, and it can be retrieved later. This is a pipeline. This is not a process. So far, the idea was this will be run as a process. But now there is a whole new phenomenon popping out of this, which is called model ops. So even the machine learning models are said to be operating in a pipeline. It cannot be anymore a process. SageMaker is a classic example within AWS world. Okay. Okay, since we are running out of time, I wanted to quote quite a few more examples, but we are short of time, then this is my last one. Okay, so this is a GitOps ecosystem. Most of the enterprise applications, again, which are in-house, not on cloud, will follow this path. This is very similar to the first slide I was showing. The entire ecosystem is within GitHub. With this GitOps workflow, pretty well you can run a large enterprise without having to procure a lot of other vendor products. Okay, so that is all I had, and since we are on top of the hour, any time for QA or no? Okay, so I'll be around here in case if you have questions, you can catch me up down the road. This is my LinkedIn as well, so that's all. Thank you for passionately listening to me. Thank you so much.
Thank you so much, Manivannan.